Hello, welcome to Unit 6, Lesson 5. I'm Professor Blackman. In this lesson, we're going to look at radical expressions and denominators. So if we have at any time a denominator, we cannot have a square root in a denominator. This also goes for cube root, fourth root, fifth root, any nth root we do not want in the denominator. So what we have to do is we have to multiply by some other value here that will turn that into the perfect cube, square, anything underneath. When we have two terms, let's say we have 3 plus a square root of x, what we have to do is multiply by something called the conjugate. And the conjugate is just whatever you have here, it's the opposite. So if we have 3 plus square root of x, then we need to multiply by 3 minus square root of x. If it's 2 minus square root of x, then we multiply by 2 plus the square root of x. And just remember, whenever we're multiplying anything by a fraction, whatever we put on bottom also has to multiply on the top. That way we're multiplying because all of this is equal to 1, and multiplying by 1 does not change anything. So let's go ahead and get started on some examples. Okay, so here we need to get rid of the square root of 5. So if we multiply square root of 5 by square root of 5, that becomes square root of 25, which then becomes 5. So we want to multiply by a term to get rid of that square root. So I'm going to multiply by square root of 5 over square root of 5. Okay, after doing that, this will add, when I multiply it, that gives me 2 square root of 15 over 7 times 5. Simplify the bottom, this will become 2 square root of 15. That square root of 15 cannot simplify, and we have a 35 on bottom. 2 and 35 are not going to simplify either. Okay, the next one, what we're going to do is we're going to split the top and bottom. So this will be the cube of 16 over the cube of 9. So when we look at the cube of 9, do some work over here on the side. Well, the cube of 9 is really 3 squared. So what we need is something that will make this a perfect cube underneath. So we're going to multiply by the cube root of 3. So now when we multiply that out, we get the cube root of 3 cubed. And 3 divided by 3 gives us 3. Because 9, we want to turn that into a 27, which then becomes a 3. So let's go ahead and multiply by the cube root of 3 over the cube root of 3. And when we multiply that out, we get the cube root top and bottom. On bottom, that's 27, which will eventually become 3. And on top, we get 48. Now we need to make sure that that 48 can't simplify. We already have 3 on the bottom. So let's go ahead and look at that 48. I'm going to break it down into its factors as 2 and 24, 2 and 12, 2 and 6, 2 and 3. So as you see, we have 3 sets of 2s, and the 6, 2 times 3 is left over. So that's going to become 2 cube root of 6. Because 48 is equal to 8 times 6. And if we take the cube root of that, that is 2 cube root of 6. So that's what the cube root of 48 becomes. And 2 and 3 are not going to simplify, so that is it. Let's look at some more examples. Okay, so here we have a cube of 5. So we have this cube root of 5c. Well, 5 is prime and c is by itself. So what we need to multiply by is we want to turn that into the cube root of 125 over times c to the third, because that is a perfect cube, which will then eventually just become 5c. So what we need to multiply by is the cube of 25c squared. So what we need to do is multiply by that cube root of 25c squared on top and cube root of 25c squared on bottom. So when we multiply that out, we get the cube root of 3 times 25, which is 75, ac squared on top, and on bottom, that's the cube root of 125c cubed. So when we simplify that, on top, we have 75ac squared, because that's not going to simplify. And on bottom, we have our 5c. All right, let's look at another one. So we have the cube of 6, which is 2 times 3. And then x to the fourth is x to the third times x. So only this is a perfect cube. So what we need is to multiply in order to turn that into 216, which is 6 to the third. And we need this to become a x to the 6, because 6 divides perfectly by 3. So this will be x to the 6th. So we need to figure out what we need to multiply in order to turn all this into that. So then we get 6x squared. So what's missing? Well, we need to multiply by 36, because that's 6 squared. This is 6, and that's 6 to the third, so we need to multiply by 36, and x squared. And of course, all that needs to be under a cube. So we need to multiply by the cube of 36x squared and the cube of 36x squared. When we multiply that out, we get cube root of 72 y or x squared, alphabetical, y to the fourth, and on bottom we get the cube of 216 x to the sixth. So on bottom we have 6x squared. We need to see if that top can simplify. So 72 is 2 and 36, 2 and 18, 2 and 9, and 3 and 3. So 72 equals 2 cubed and 3 squared. And so that 2 cubed is going to be able to be factored out. So that 2 is going to come out. And then when we look at y to the fourth, well, that's y to the third times y. So that y to the third can come out. And on the inside, we are left with, from the 72, we pull out an 8, leaving a 9. And x squared. And for the y to the fourth, y to the 3 got simplified, leaving a y on the inside. All right, let's go ahead and look at some more examples. So we needed to take our square root and split it up the top and the bottom, because we've learned that on a different video that we can do that. And then we need to simplify this. So let's go ahead and multiply by what's on the bottom, which is square root of 20 over square root of 20. And so that on the bottom will give us 20, square root of 400, which becomes 20. And on top, we have square root of 60x. And 60, we can break that down as 4 times 15x over 20, which becomes 2 square root of 15x over 20, which then 2 divided by 20 becomes square root of 15x over 10. Now, I worked it that way, but I want to show you a separate way that we could have worked that same problem. So if I had taken the square root of 3x and the square root of 20, if I had simplified square root of 20 first, which is square root of 4 times 5, so that becomes square root of 3x over 2 root 5. So now instead of looking at square root of 20, we're looking at 2 square root of 5. Now I can multiply by square root of 5 over square root of 5. And when I do that, I get square root of 15x over 2 times 5, which becomes square root of 15x over 10. So it's up to you whether you simplify first and multiply by a smaller number, or if you multiply by the bigger number and then simplify at the end. But at the end, you can see that that number and that term, those terms are both the same. All right, let's look at our next example. Okay, so we're going to split this as the cube of 4 on top to the cube of 5x to the fifth y squared on bottom. So we need to figure out what I need to turn that in. So I have 5. I have x to the third, x squared, and y squared. So this one, I'm going to go ahead and change colors. We need an additional 5 squared to turn that into 5 to the third. This one, we need an additional x, and this one, we need an additional y. So we're going to multiply by the cube of 25xy. That's what we need to multiply by. So let's go ahead and do that. Multiply top and bottom by the cube of 25xy. Okay, on top, that will become the cube. 4 times 25 is 100. xy. And on bottom, we have the cube of 125, x to the sixth, and y to the third. So now we have 100, which if we break 100 down, we have 2 and 50, 2 and 25, 5 and 5. So as you see, there's no to the thirds. This is 2 squared and 5 squared. So there is no third, so that is simplified on top. So we have 100 xy, and then on bottom we have 5. 6 divided by 3 becomes x squared, and then y to the third divided by 3 becomes y. All right, let's look at some more examples. So now we have two terms, and in order to get rid of those roots that are on the bottom, we multiply by the conjugate. I talked about the conjugate at the very beginning, and basically what happens is if we have a plus b, we multiply by a minus b. Or if we have a minus b, then we multiply by a plus b. But that is the conjugate of it. So here we are going to multiply by 3 square root of 2 plus the square root of 5. And on bottom, same thing, because we have to multiply by top and bottom the same thing, because that's equivalent to 1. All right, so we need to multiply this out. So 6 times 3 is 18. Square root of 3 times square root of 2 is square root of 6. Plus, bring your sign down, 6 square root of 3 times square root of 5, square root of 15. Over 3 square root of 2 times 3 square root of 2 would be 3 square root of 4. 3 square root of 2 times square root of 5 would be plus 3 square root of 10. And the middle would be negative 3 square root of 10. And then the last two terms would be negative square root of 25. So then we end up with 18 square root of 6 plus 6 square root of 15 divided by 3 times 2, because square root of 4 is 2, 3 times 2 is 6. Middles cancel, minus 5. And so 6 minus 5 is 1. And so when we divide by 1, we get 18 square root of 6 plus 6 square root of 15 over 1, which is just 18 square root of 6 plus 6 square root of 15. All right, let's look at our next one. So the conjugate of the bottom would be square root of 7 plus square root of 5 over square root of 7 plus square root of 5. Make sure we multiply top and bottom by the same thing. So on top, we have negative 5 root 14 minus 5 root 10, all divided by square root of 49 plus square root of 7 times 5, 35, minus square root of 35 minus square root of 25. So then we have negative 5 root 14 minus 5 root 10 all over, middles cancel again, 7 minus 5. So we get negative 5 root 14 minus 5 root 10 over 7 minus 5, which is 2. So that's how we multiply by conjugates. Let's look at some more. All right, so here we're going to multiply by some conjugates again. So here we're going to multiply by square root of 2 minus square root of 5 on top and bottom. Now, since I'm multiplying by 2 terms on top and bottom, what I typically like to do is just somewhere on the side do that math. So I'm not having to rewrite a bunch of things a bunch of times. So 3 times square root of 2 is 3 root 2. And then 3 times the last term would be negative 3 root 5. And then square root of 5 times square root of 2 would be square root of 10. And then square root of 5 times negative square root of 5 is negative square root of 25. And then I'm going to see, it doesn't simplify, but this will simplify to minus 5. So on top, I have 3 square root of 2 minus 3 square root of 5 plus square root of 10 minus 5. Okay, and then I'm going to do the bottom. And so with the bottom, I have square root of 2 times square root of 2, which is square root of 4. And then square root of 2 times the back would give me negative square root of 10. And then square root of 5 times square root of 2 would give me plus square root of 10. And then minus square root of 25. Middles cancel, and we get 2 minus 5, which is a negative 3. So I can put all of this over a negative 3. And you can leave it like that, or it is preferred to take that negative and kick it out to the front. And then we have 3 square root of 2 minus 3 square root of 5 plus square root of 10 minus 5 as your solution. All right, let's go ahead and do the next one as well. So what we need to do is multiply by our conjugate, which is square root of 3 plus square root of 7, and we do that on both top and bottom. Okay, and so let's go ahead and do that. So square root of 3 times square root of 3, square root of 9. Square root of 3 times square root of 7 is square root of 21 minus square root of 6 minus square root of 14. And as you see, all of those, none of them are like terms, and this one does simplify to a 3. So the top would become 3 plus square root of 21 minus square root of 6 minus square root of 14. All right, let's do the bottom now. Square root of 3 times square root of 3 is square root of 9. And then we get square root of 21. And the middle 2 terms gives us negative square root of 21. And then the last 2 terms give us a negative square root of 49. And as you see, middle terms cancel. and we get 3 minus 7, which is a negative 4. And we're going to divide by that negative 4. And then typically with math, we don't want that negative out in the denominator, so we would kick it out in front. And we'd have 3 plus square root of 21 minus square root of 6 minus square root of 14 as our solution. All right, let's look at our last set of problems. So here we need to multiply by our conjugates again. So the conjugate would be 3 minus square root of a. All right, I'd like to do all my work on this side. So 2 times 3 would give me 6. 2 times negative square root of a is negative 2 square root of a. Negative square root of a times 3 would be negative 3 square root of a. And negative square root of a times negative square root of a would give me plus square root of a squared. All right, now we can simplify this. 6 stays 6. Negative 2 square root of a and negative 3 square root of a give me negative 5 square root of a. And square root of a squared is a. So we can rewrite that out here as 6 minus 5 square root of a plus square root of a. All right, so let's do the denominators now. 3 plus, I'm going to rewrite it so we can see it all here. And 3 minus square root of a. 3 times 3 is 9. 3 times negative square root of a is 3 square root of a. A square root of a times 3 would be plus 3 square root of a. Minus positive times negative is negative square root of a squared. This canceled, and we get 9 minus a. So on bottom, we have 9 minus a. And there's no GCFs that can be factored out, so that is our final answer. All right, let's do the next one. So our conjugate here would be 3 minus 2 square root of x. Because it's the same as the bottom, opposite signs. So let's go ahead and work this problem out. So on top, we have 2 times 3, which gives us 6. 2 times negative 2 root x would be negative 4 square root x. 3 square root of x times 3 would be a positive 9 square root of x. And positive times negative gives you negative. 3 times 2 is 6. And square root of x times square root of x is square root of x squared. Go ahead and simplify that. That gives us 6. Negative 4 plus 9 would be a positive 5 square root of x. Minus 6 square root of x squared would be 6x. So on top we have 6 plus 5 square root of x minus 6x. And now let's go ahead and do the bottom. So 3 times 3 would give us 9. 3 times negative 2 square root of x is negative 6 square root of x. 2 times 3 gives you plus 6 square root of x. And 2 square root of x times negative 2 square root of x gives you negative 2 times 2 is 4. Square root of x times square root of x is square root of x squared. And then middle cancels out, and we get 9 minus 4x. So on bottom, I'm going to put that as 9 minus 4x. And as you see, there's no GCF, nothing's going to factor, so that is our simplified answer. That's all I have for you today. Happy studying.